So chapter 3 opens with a quote from Francis Crick, who was one of the discoverers of the double helix structure of human DNA. Um, Almost all aspects of life are engineered at the molecular level, and without understanding molecules, we can only have a very sketchy understanding of life itself. So this chapter is about molecules and compounds. We've talked about elements, and elements can combine with each other to form compounds. There are 91 naturally occurring elements, and they can combine in various numbers and combinations, which gives us an almost limitless number of compounds. So we see huge diversity in properties among the substances around us, and those are due to the tremendous variability in the formation of compounds. So if we look at just the combination of hydrogen and water, we could make two compounds from hydrogen and water. Hydrogen and oxygen. Hydrogen and oxygen make water. So if we combine hydrogen and oxygen to make water, we see that there's a huge change in the properties of those substances. Hydrogen and oxygen are both gases. At room temperature, hydrogen is explosive, oxygen is necessary for combustion. Water, the combination of those two elements, is a liquid at room temperature, and not only is it not flammable, it's used to extinguish flames. So we get an entirely new substance when two elements combine. An example of the general public not understanding this is the concern about mercury in vaccines. So thimerosal is used as a preservative. Thimerosal contains the atoms of mercury. But having mercury in a compound is not at all the same as having elemental mercury. Elemental mercury is very toxic, but in a compound, it is not necessarily at all harmful. Just like here, we have hydrogen gas is flammable. Does that mean we have to worry about water exploding? Because hydrogen's flammable and there's hydrogen in water, right? No, it's a different compound. The properties are entirely different. We can compare mixtures and compounds again. We've talked about this, but now we'll talk a little bit more about that. A mixture is where you have elements that are in any proportion. This balloon is an example of a hydrogen-oxygen mixture. We could have equal parts of hydrogen and oxygen gas. We could have a little bit of hydrogen, a little bit of oxygen, and a lot of hydrogen, etc. Any combination is possible. In a compound, the elements are combined in fixed definite proportions. It's always the same ratio. So here is a sample of water, and all of these molecules contain one oxygen and two hydrogen atoms. All of them, every single one. Okay? Actually, let me move back to that for just a minute. Another way to identify a mixture versus a compound, when we look at the components, the individual particles in this, we see there are two kinds. There are the red ones and the white ones, right? They're each composed of two atoms, but there are two distinct types of molecules. Here in the water, every one of these molecules is the same as the other. So that's characteristic of a compound. Any questions?
So if you just put hydrogen atoms and oxygen atoms together in a container, they'll naturally...
They'll just mix and nothing will happen. Yeah, they will not spontaneously form water. In order to form water, you would have to give it some input of energy. If you bring a lit match near that balloon, then it will explode, and in that explosion, it converts into water. Hydrogen and oxygen combine to form water very violently, and they release a tremendous amount of energy. But they won't just do it spontaneously. It needs a spark or something to get it started. It's a good question.
So that's not a sustainable way to create water?
No. it's not a sustainable way to create water. The real problem with that is, where do you get the hydrogen and the oxygen? Yeah.